Okay, so this is the audit stream, everyone. This is session 3H, and Coleman is going to talk about the diminishing returns curve, or audit 101. Please feel free to stick any questions in the chat, and I'm sure at the end we can unmute you all and you can ask directly if you want to wait. Can you please provide feedback at the end of the session? There is, you can either click on the agenda, or at the bottom of the presentation, there is a code that you can see there, a QR code that you can click on. Okay, over to you, Coleman.
Okay then, hello all. I never have, let me have a look at just trying to get myself organized here like I'm saying. So if you can all see me, I can't see you, but that's okay. I may do gestures depending on how it goes, but yeah, welcome all and welcome to this it's true that I called it a diminishing returns curve in the beginning, and you'll see what I mean by that, but it's not really about the curve. It's more about Audit 101. It's all about the basics of auditing, and I've been doing this for years, and more and more I get beginners, or not necessarily beginners, but auditors that coming from outside the mainframe into the mainframe, and they want to know what questions to ask and that kind of thing. So maybe you guys heard that kind of situation, or that's what you think, but we'll see. In any case, we have a little bit of time, so I'll just go with this and I'll talk a little bit about me. Well, I've been in the mainframe business since 1991. I wrote TPF assembler code for the mainframe in the UK, USA, Germany, and France. Came to France in 97, but moved to ZOS in 2002. ZOS, I suppose I should be, it's ZOS. I can't remember English or American for ZOS, but we'll figure it out. You guys know what I mean. And since 2008, I've been training the mainframe, and it's true that you learn a lot about how it works on the inside training. And I love the training part of it, and this is part of it as well. Now, on this conference, unfortunately, I can't see you, so I can't see if you're either listening or even understanding what I'm saying, but that's how it goes. Maybe next time we'll get to see each other in face-to-face, because it's much better. And, of course, for any kind of thing like this, everything I say here is mine and mine alone. There's no, don't quote me, I suppose. It's my observations, simple observations over the years, and it's the little things that count. And I'm giving you really my opinion on the subject, and I would be happy to afterwards to elaborate much more. It's a big business, obviously. Like I said, anything I say here is not to be taken as any kind of endorsement or any kind of product or service. Obviously, IBM is the figures very, very highly here, but I shouldn't really be talking about anything else. What else did I say? Hold on a second. I'm missing my. Hold on a second. Why is that not? There you go. Oh, there we go. Obviously, a basic audit. You can't certainly say that you're secure if you do a basic audit, but you can say that you can be more secure. There's no harm in getting better and better as we go. It's a work in progress always, and always continuous improvement. All we do. I talk about RecF a lot here. That's my basic thing, but the concepts are the same no matter what. So I'm going to talk about this famous curve, what it is, and where we are on it, trying to find out where we are. Beyond that, the big one about the audit is the following topics. Is everyone identified? Is it possible to identify everyone in your machine? We'll talk a little bit about the internals of ZOS and what that means. Is everything protected? Well, obviously the data sets and everything according to the rules. And what are the rules? Well, how do you find out the rules? We'll see that a little bit in a minute, but that's kind of what we're going to talk about. Everything logged. Well, obviously security breaches are a long game. You need to be watching everything all the time. And because if people get into your system, they'll do things slowly but surely and quietly. You need to be logged everything. I didn't want to put this in writing, but obviously if anything does happen, you really need to be able to look at the logs and find out why. But hopefully you'll be watching that well before anything happens. Everything encrypted. Well, this is a long story because up to a point, because I'll talk about the curve now the curve in an instant, and this is the whole the premise of this. It's a question of how much work for how much gain, and this is what this will mean. Do you know what your job is? We'll talk a little bit about your roles and responsibilities given given your job and what you have to do about it. Now, for a long time, I've given classes about all sorts of different things, and especially security. And I've always drawn a diagram on the board that says, well, in the beginning, where's my cursor? I can't find my cursor. Where's my cursor? Because I wanted to be able to point out. Hold on. I don't have my cursor. There's the cursor. Can you see my cursor? There we go. I'll see my cursor like I'm down. In the beginning, we're down here. And a little bit of work will get you very secure. But the more work you do, the curve diminishes off a bit. It's just a reality. In France, I talk about the quality of wine and the price you pay for a bottle of wine. Here, we're talking about you can get very good wine very quickly, but once you start doubling the price in the thousands of euros, the quality is diminishes. The extra quality diminishes. A small amount of work will give you a high to reasonable gain, but then over time these increases become less significant, and this is the point. You cannot, malgré, despite what anybody will say, despite what any vendor will tell you, there's no such thing as 100%. There's always a human factor. There's always, and we're human. We make mistakes, and you can get as close to 100%, obviously, as you can, but it is a constant vigilance. And the point about this here, the whole point about this teach is there's no real point in working here on this part of the curve if you haven't got this bit right. And today, this is what we're going to try and talk about, this first bit, and see where we are on that. This is what we're looking at today, like I said. So in terms of the big picture, we have what I would call the security pyramid, and I found this image. I found this image in many different times. So it's a little bit about where we are. In many times of audit, it may not be your job, but physical procedural security does come down to who can actually get to the machines on the disk base. I mean, obviously with SSD disks now, if you can walk into a data center, you can take your SSD disks. They're not very heavy. When I started in this business, the disks were really big and really heavy, so nobody could really walk away with them. Nowadays, that's a thing. Beyond that, integrity. Well, can you actually trust what's going on in your system? You can do all the security work and everything, but if you have a piece of code that's faulty, then it all goes to pot. There's nothing you can really do about it, but you can. We do, by definition, we trust the code that IBM sends us to run on our systems. It's we're talking about the kernel of ZOS and all the products that go with it. Kix, DBdo, MQ, all of these things are I suppose guaranteed by IBM. It's something we have to live with. But I'll talk a little bit more about what extra we can do. In this universe, resource asset control is something, the way in which we look at security in ZOS. We call it that, well, can somebody do something? Basically, it's a kind of thing. And most of the security mechanisms in ZOS are what I would call abstract, but we'll see that shortly as well. And then beyond that, encryption. Well, encryption obviously is at the top of this curve. There's really no point in putting encryption in place unless you have everything else. And this is it's all about knowing, doing the beginnings of it, getting it right before, because audits always start at home, and you want to get your shop in order as best you can before you start buying new products and before you start getting experts in to really do the security. If the expert comes in and says, well, look, not everybody has a password, you kind of really need to be doing that yourself before you even start. So where do you start? Well, you need to know your rules, because the rules obviously are different, and depending on a company, there obviously are basic ones, nothing to be talk a little bit about it. But then it's about how your company does it. And obviously, every company, I guess you guys are coming from banks, insurance. This is the business we're in. You I did some research for this thing, and I couldn't find a definitive term for the document that says your enterprise policy or information security policy. But in any case, no matter who you work for, you got to have a document like this. I think we maybe the document must exist. There must be a CIO. There must be a CISO. There's all sorts of different acronyms left and right like that. But there's somebody somewhere at the top of the chain who is responsible for all this, and this person will have this document. And that's really where you have to start, because that's audit 101. This document obviously will have generalities about authentication, password, or strong authentication. It'll have password length and complexity. It's all down to the passwords. We'll see that in a minute. Expiration. It expires every week. It expires every 6 months. It expires never. Obviously, that's how it goes. And then whatever change passwords you can do, that's you need to really know about. Beyond that, there will always be specifics about data classification. They talk about public, private, top secret, internal, left and right. This really is, how shall I say, this is company specific, obviously, but this is the kind of thing you need to know in the very beginning. Roles and responsibilities, well, who does what? And this is one of the hardest ones, because especially in the mainframe world, when these guys have been doing, people like me have been doing it for 35 years. I couldn't actually tell you exactly what my role is, but well, I can, but I have many, many different roles. On a security aspect, it must be much more defined and much more squared away. You need to be able to do that. But obviously, then the mainframe is different. If you're coming from the world outside and you're coming to the mainframe, there are differences, and I'll talk a little bit about the difference now in the next couple of slides, because ultimately, when you talk about the differences in the mainframe, you need to go and talk to the person who manages this document, this famous document, to explain and mitigate the differences, because there's just things we cannot do on the mainframe. There's things that we can do in Windows and Unix and Linux and all the other IT systems, but there's just some things that we can't do, and we need to either change it or live with it, depending on the thing, depending on where you are on the curve. Because if you're at the top of the curve, you're good. But if you're at the bottom of the curve, these are not the most important things in the very beginning. But the differences for the mainframe, obviously, for anybody who knows mainframe, these will be obvious. But for people who have never seen the mainframe, it's a little bit strange. There's an 8-character identifier, and unfortunately, that's architecturally set in the beginning. If you use the mainframe, you have a user ID or an identifier or an account that is 8 characters long, which is by definition not very much. Okay, but it's not. It's even the biggest corporations, the biggest bankers corporations, 8 is enough. But there's no indication with this identifier, and the hard part obviously is trying to correlate this identifier with whatever you have, because obviously on Windows you have a username. It's a bit longer. Different systems have evolved over the years. This is the one thing that hasn't evolved on mainframe, but we have to live with it. I asked my colleagues yesterday, in fact, is there any plans, or have there ever been any plans to change this? As far as I know, there's no plans to change this. If anybody out there has ever talked about that or thought about that, I'd be interested. The 8-character password. Now, this is the biggest one on the mainframe that has been around for years and years and years and years and years. And at the moment, everybody's moving away from this. Everybody's moving away from this. And my advice to you is to not even, and I had an argument, I had an argument with a colleague this morning even about this, and he said about mixed case and special characters, the relatively recent innovations in RACF and the external security managers. My take on this is it's easier to go to the modern technologies, rather than really, if you're moving from ordinary passwords, to this mixed case or special characters, I wouldn't bother. I would go straight to passphrases or multi-logon. I'll talk about that in a minute. It's a question of the mixed, and then beyond that, the mixed characters. I work in many different countries with many different code pages. So if you have many different systems talking to each other, you're worried about if you don't know what that code page issue is, then it's different mapping, different language mapping for different languages like French or German or Italian. And even the UK and the US have different code pages. So the same binary data won't necessarily show up the same way on the screen. And that's just something to look out for if you are going to use special characters. The modernization possible, we'll see that a little bit later. The other mainframe distances, well, we talk about data sets and not files. In all the universes, in all the other IT platforms, the files themselves know a little bit about their security. In ZOS, the protection for these data is abstract. And what does that mean? Well, it means that the object or the data set that is protected has no idea if or how it is managed or protected. There's nothing. I'll show you the next slide will show you about how this works. But ultimately, the questions there's no security information that travels with the file. In Unix or in Windows, you copy a file from one place to another, it keeps its security information. In ZOS, we do not have that. It is an abstract question. Oh, and you got Unix in there too. I don't talk much about Unix here, but it's a whole other universe that's right in there, and it's been there since the 90s, and it has all its own particular quirks about security. But having said that, if you are coming from the Unix environment, on the Unix or Linux world, the security is very similar on ZOS Unix. So don't worry about too much in the beginning. So ultimately, I talked about item number 1. Is everybody identified? Well, the idea that everything that happens in your system must be loggable and attributable to a user ID account. Nobody should be doing anything on the machine that isn't just, in the background or no user ID, whatever. It's if at all possible. And there's some things that you can't, but that's we'll see that in a minute. But the idea is that everything should be everyone and everything that happens should be accountable. The big one there, obviously, is the classic case of one KICS group, one CCS group somewhere, and there's 20 people that manage KICS, and they all use the same user ID to log on and manage KICS. It's very rare nowadays, but we saw that a lot in the early 2000s, where traditionally there was one admin user for KICS. Maybe you've seen that kind of thing. Obviously, the human users, well, anybody who needs to connect to the machine directly or indirectly, and this is a hard one because figuring out any indirect connections is not easy in the beginning. But yeah, you got to start somewhere. So directly, the actual human interaction directly needs to be. Again, we're back to roles and responsibilities. If they do connect directly, well, what are they actually doing and what they have to do? And that stuff needs to be identified. Beyond that, then you got service users, because ZOS is a service. It's a server with services running all the time. So you need to be watching out what these guys are doing, because eventually these guys can be hijacked by humans to do bad things. Now, I didn't say that earlier, but my take on this auditing and security over the years has always been about us protecting us from ourselves. The security in the original security issue with the mainframe was stopping people deleting stuff by accident. Really, that's and we're still there today. Really, we want to protect ourselves from doing things by accident, and these are the service users as well, because these users have loads of power and they need to do stuff. We're talking about schedulers, we're talking about system automation, and where is that? Oh, my slide is okay. There we go. System automation and internal processes. Well, there's all sorts of stuff that happens. Oh, there's a delay. Sorry, there's a delay on when I change. Okay, excuse me. Internal processes. We're talking about things like catalog, logger address space, console, stuff like that. They run all the time in ZOS. but they run under what user ID? They have a lot of power, so we need to be able to check them. I just a little slide here about the new thing. 3.1 is a new thing. I'm very technical, so I apologize to people who are not tech, but this is a new thing that came along in SDSF in ZOS 3.1. You have a little thing called a little option now that calls a job task command on an active address space. And on the job task command, you can actually go in there and see the ACEE. And the ACEE is the actual security control block for any given address space. And the display is once you get in the JT column, you find the ACEE, and that will bring you all the way down to the user ID that this address space is running with. And the plus here, this is the thing that is just a weird one. The plus here indicates that it's a default user ID used by ZOS. It doesn't exist as a user ID. And the idea is for every new version of ZOS, I look at if these system address spaces can be attributable to a user. Obviously, if you cannot change it today, it may come, but you need to guarantee, you need to be sure and trust the code that's coming from IBM, because these are obviously kernel modules inside inside your ZOS. The good news is there's very few. I counted about this morning. I counted about 5 or 6. They're very, very low down, and they have all sorts of security messages otherwise with the PPT. User IDs and password authentication. Well, obviously, I said I'd come back to this. Traditionally, 8 characters or 7 for TSO with an 8-character password. So, people had passwords like APRI 2025, and you'll all agree that's a great password, right? That's it is how it is, and it is how it was for many, many years in my universe. Obviously, we have many, many modern mechanisms to improve this, and innumerable. And if I go through them a little bit, obviously passphrases. Now, passphrases obviously can be 9 to 100 characters with built-in rules, left and right, all the rest. I'm not really a fan of passphrases personally. Like I said in the beginning, these are my opinions. Passphrases are just too long to type. Really, it's just as a human, I have other mechanisms. The ultimate, you'll see now in a minute how it works. But passphrases is obviously hugely increase in security as opposed to the 8-character passwords as they used to be. Multi-factor. Well, this is the big one now, where everybody's aware of this, what it is, how it works. There is you are logging onto your ZOS, and it's some mechanism internally allows you to check externally, be it LDAP, be it any kind of other mechanisms, check externally for authentication, and it's a yes or no answer. It's very cool when it works, and a little bit again up the curve a little bit on how it begs, but certainly recommended. Like I said, there's Radius, Ping, Duo, Secure ID, among many others. I don't necessarily recommend any, except maybe Radius, because Radius is the protocol. Radius is not a company in itself. So if you can do Radius, you can pretty much talk to any external site. Single sign-on, well, it's the same kind of thing. We're talking about Kerberos, or some other external mechanism. If you can put that in place, well and good. It really does help the user. It's about the user and about being able to sign on in the beginning and having that being propagated for any other things that you want to do during the day. Again, harder to set up, and the ultimate is the single sign-on has to be super secure. So we'll be talking about single sign-on with multi-factor, for example, the two together. The single sign-on will also allows, depending on how you set it up, user ID mapping on ZOS, which means that you log onto Windows with a big user ID. You don't even know your ZOS user ID. You don't even have to know, depending on what you're doing inside. That can work. Go see. My personal favorite is client certificate authentication. I do a lot of work with certificates and keys and private and public keys and left and right knowledge, trying to go with it. That's how I've set it up for me. I have a client certificate on my local device, and that's the one that really needs to be protected. But once you have that, then logging on is pretty easy. Hard to set up. You need a PKI infrastructure. You need some mechanism to manage that. And you can also mapping. There's a very specific host ID mappings extension for the certificates. I've given the code here. There. I discovered this last year, which means that ZOS can take your user ID from the certificate. So you can have that all locally and protect it locally if you like. And then pass tickets, obviously, this is absolutely wonderful when this is in place, because this is part of the single sign-on mechanism. If you sign on to one ZOS and you go through the very secure process, beyond that, then ZOS can be very strong and generate pass tickets for other applications left and right, and can be very secure. I missed out the word enhanced. Sorry, I should have put the word enhanced here. Is what IBM calls enhanced path tickets. If you can do enhanced business, it's super secured, obviously, but that's obviously a thing. Particular user attributes. Well, when we look at users in ZOS, how am I doing for time? Ooh la la. Okay, I better hurry up. It's a RecF specific, but this could happen for you. But this is my take on it. There's a thing called operations attribute in RecF, and the idea in 2025 is nobody, human or otherwise, should ever have this attribute. I'm one of the people. I've worked 35 years with IBM, and sometimes I love, sometimes I hate. It's a whole love-hate relationship with IBM. This one, operations, I would like to see IBM just take it away. It's obviously it was a legacy from the 70s, 80s when this thing was done. Today, there's absolutely no reason that anybody should have operations. It's except maybe for emergencies, but we'll see. HSM, any other data management product, can and should be specifically permitted. This is just how it is. There's nobody. You will get some of the old guard in mainframe saying, "Well, I've had operations for 30 years, so I'm keeping it." But there we go. We're back to the politics, and today I'm not really going to talk about politics. Obviously, if your emergency situation means that somebody somewhere gets operations, well, obviously that has to be well defined and has to be logged accordingly. There are better ways to do it, but again, when it's an emergency, it's a difficult call. And I did talk about your roles and responsibilities. The real question here: whose call is it? At that point, that's these are the things you need to know. I mean, who does what and how we go with it. RACF special, obviously, the RACF administrator, and it's very key here that says RACF special gives you no permissions in and of itself. And that's just how it is. But obviously, with RACF, you can give yourself any permission, and it's a kind of a double-edged thing. But we talked about logging anyway and how that works. Obviously, the auditor would be you or me, and the auditor is, you're really there to, I would call that internal affairs, or in French they call it la police de la police. It's the police of the police. It's not quite that, but these two roles, special and auditor, are two different roles, two different people, and these people honestly should not be eating in the same canteen, but this is what happens sometimes. There's obviously a conflict of interest between these two things, but the auditor is needs to be knowing what's going on. There's a new RACF thing called read-only audit, and I'm not sure. I would, if this was an interactive session, I would be asking you, who do we give read-only audit to? I'm a taker. I have my own ideas on the subject, but I'm a taker for other people's ideas. It's a very clever, very clever new little option to allow anybody to look at what's in the RACF database. But yeah, open for debate. So that's about users, obviously, but beyond users, then we're talking about things. I mean, it's a who and a what. I'm always talking about a who and a what in this universe. It's a who can do what, and the what is a kind of a what we need to be protected. But to understand the what, I'm going to just do a quick one about how the ESM works instead of us. is everything protected? And how it works very simply is that the calling application, the programmer, be it a programmer in, where's my cursor gone again? There we go. Be it a programmer in Poughkeepsie, New York for IBM, or be it a programmer right next to me because we're an ISV, we do software for the Z. Somebody somewhere codes what we call a rec route authorization or a rec route extract. There's many, many different types, but the authorization always has a notion of who, what, and how. That goes out then to what they call the SAF. Well, the SAF is just an API put in place by IBM to allow effectively an external security manager. And today, as far as I know, there are 3 external security managers: RACF, TSS, and ACF2. Doesn't matter because the concept is always the same. And he will consult his database and answer. And we know this: return code 0 is okay, 8 is not okay, and 4 is I don't know. That's how it is today. Now, lots of other information comes back, obviously, but in the end, it's all fairly standard. But ultimately, then, it's the calling program that decides. So if there's this program, if the program decides to do something else, then well, there are other mechanisms in place. We'll talk a little bit about them in a minute. But this logistically or logically, this is what happens. And this is what I said earlier about if somebody is asking permission to read a data set, the information about the protection for the data set is not with the data set. The information is all the way over here in the external security database, and the information is abstract. It's here that it says. And the external security manager is completely ignorant as well. He will just answer questions. The ESM really just answer questions, and we trust that the application program will act accordingly depending on the answer. Beyond that, then, is everything protected? Well, your data. Okay, we have the data. We're talking about all data sets. There's no brainer here. There's no reason for any data set to be not protected. You have a protect all failure in RACF on the ESM equivalent. The system critical data sets. Integrity. We talked about integrity, and these are things like nucleus, SVC lib, LPA lib. Now, nowadays, then, this code can now be signed, and there's a thing called validated boot that's coming up very hard and strong, but validated boot is at the top of the curve. So don't worry about validated boot for today. It's a great thing. It's an excellent thing, but it's quite high, and it's quite a bit of work. Everybody will tell you it's easy. Everybody trying to sell it to you will tell you it's easy. I've looked at it. It's not easy, but it's not, it's depending on everybody has their own attitude about things being easy or difficult. So as a trainer, I think I'm a little bit better placed to judge on that. Beyond that, then, system privilege programs are everything in what we call the PPT and the LPA. If you don't know what these things are technically, this is, you need a follow up. But these are programs that come from IBM and beyond that actually need to bypass security for performance. They need to be fully trusted, and there's obviously an issue. We need to trust IBM, but we need to also talk to our other suppliers about this code. How much do we trust them? User privilege programs is the APF list. Now, you've all probably heard of the APF list, and I don't have time today to go into what it is. Just know that it's super, super, super important, and that on a security level, you really cannot neglect the APF. So PPT, LPA, LPF list beyond, and then user data. Well, it might seem like an aside at the end, but we're there. That's our actual reason to be, is the data, and we're morally obliged to protect it and legally obliged to. So that's not to be forgotten. But again, we're on the next bit. I'm looking at the time. Okay, I'm gonna have to speed up a little bit. Is everything protected? We're back to everything protected. All system commands. Now, this is a non-exhaustive list, but anything like IADFs and activate and cancel, force, modify. You could really mess with the system if you can do these things. And obviously the command set. This is the big one. The big one in all its forms: set prog, set SMS, set OMBS, etc. And don't forget, set prog equals, and set SMS equals, and set OMBS equals. I won't go into the technicalities of this, but just know for now that these two objects are different. They're two different things that need to be protected on a technical level. What else have I got? This is also a big debate. If this was interactive, I would have a big debate with you about this. You obviously have your own thing. As a system programmer, I would say yes, because a system programmer can find out this information anyway. Blocking the displays it's a question. Do we let ordinary users look at everything? The whole point about security is that if you can see something, then you know how to hack it. But anybody who really wants to hack it, it's more work for very little gain. And this is what I'm trying to get at here. Well, obviously, then there's the system logger and BPCII. These are two things. There are more, obviously, but these are the two things that came to mind. You need to protect the logs, and BCPII is a very, very powerful a mechanism for a ZOS instance to mess with the whole machine. It's ZOS talking to the machine. Is everything logged? Well, you need to log everything. It's 3 a.m. Do you know where your syslogs are? We'll talk about ICH 408 and talk a little bit about SMF. I'm really running out of time. Where are the logs? We got upper log, sysview conful, syslog D. Do you know where it is? TRMD, not always necessary. SSH, where are the logs? And this is the message here: is get the timestamps correct. If you're anytime working outside of time zones, left and right, the time zone here is very important because of the way the time change that goes with it. We're talking about the third month, 5th Sunday in the third month in this one, because we're not in the US. You guys are mostly in the UK, I would say. And we change time different than the US, and it's a real mess trying to look at logs if the timestamps are different. Yeah, and this one goes into language environment, CE, PRM, and the parameter. ICH 408. This is very simple. In any form or fashion, the message will give you the user, the group, the resource, the class, what was asked, and what was given. And you got a user, training, okay, you got the item that you wanted, what happened, the actual RACF object that blocked you, and what you wanted. Read, access allowed, none. And that's very straightforward. There's at least 90 different variations on this message. I counted them this morning as well, and I'm not going to go into all of them. But one of the most ones that we get that confuses people is this kind of one, because you do have the who, and you do have the what, but you don't have the why. And define as insufficient authority. That's how it goes. And normally this means this would bring me the protecting RACF is not displayed, and this brings me over. You need to dig a little bit, and brings me over to here because this is what we have in RACF ultimately, and it's the alter. It's the alter access when you're creating, renaming, or deleting an object, and that will that's the situation. That's one of the situations where you have an ICH 408 which doesn't tell you why a certain thing wasn't done. For SMF logging, I'm really running out of time. You've got SMF is the logging, is the constant logging that's always happening in ZOS, and it should always be happening in the background. You need to make sure that that's happening. Traditionally manned data sets and log streams, that's just a technical bit, but we need to log everything. The SMF types in general are 80, 81, and 83 for the different types of log. You need to be sure that you're actually doing that. There are others, 82 for ICSF. Obviously, you need to dig a little bit into your policy for that. Make sure SMF output is not dummy. I don't know how many times I've seen this. That means that dummy in this context means that you record everything, but when the data set is full, you just dump it. And I've seen that too many times to count. You can now SMF data. My colleague this morning said absolutely SMF data must be signed. I changed it to should be signed because it's a little bit higher up on the curve to signing the SMF data. It's not one of the beginning bits, but again, depending on your priority. The SMF data post processes can be examined in near real time and sent to an SEM for alerts. That's a choice that you have also. That's just a little slide that says how these types are coded in the SMF PRM member of your ParmLab. Encryption. Now, this is the one that going very quickly. It's 2025. Everything should be encrypted when it's traveling. Okay, everything in or out needs to be encrypted when it's traveling. Obviously, TLS 1.3 if we can. As I say here, the most secure possible if we can. That's depending on who you're talking to. There's a whole lot of tools to check this and work with this. I'm not going to go into that. But don't forget VTAM, because VTAM is a little network thing that's still there, and there are systems, legacy, there are ZOS systems out there that communicate only with VTAM, even still today. That doesn't have to be, that shouldn't be neglected. Data at rest, obviously, well, the modern displays are already encrypted. They should already be encrypted. ZOS doesn't see it. And then the next one then is pervasive encryption. And my colleague said that was easy. I said it's hard, but it's higher on the curve. I would call that priority one after you've done the basics. This is pervasive encryption. Once it works really well once it's in place. But again, we're always talking about the amount of work and the amount of and I discovered this the other day that even on a Z16, there's something called transparent memory RAM encryption on the Z16. Don't ask me about that for the moment. I'm still looking into it, but it does. So everyone knows their role, responsibility. You need, every time something changes, you need to have a correct process for these changes, because obviously in a security environment, you're adding users, deleting users. That's the most thing that's happening. New software, you need to go. System upgrades. These are the things that change, and these are the things that really need to be need to be followed. But for emergencies, this is the hard one. You need to watch out for emergencies and watch out for the holes. If it's too easy to break the glass, if it's too easy to get the envelope out of the drawer with the master password, if there are non-expiring passwords, you've really got to watch out for that. Beyond that, and finally, what's your decisional mandate when there's a problem? Who does what? Knowing your roles. There's always many ways to fix a problem. I mean, I always talk about, well, a guy doesn't have access to a data set, just give him operations. Yeah, but we don't do that, obviously. But you need to know how to do it, how we're going to use the readout, and what to do when something goes wrong, and who you're going to call. These are the things, certainly in the beginning, that you need to know. So in conclusion, and I'm nearly there, 58, don't panic. Know your rules. Everybody identified, everything protected, everything logged, everything encrypted, and everyone knows their job. That's my speech for today. Thank you for listening. And beyond that, then, I don't know if we have any time. I have a couple of things. How to contact me. And as always, in these sessions, you got a barcode, and they love that you give a feedback. I'm at 58, lad, David. How are you doing? How many people did I have in the end? I didn't even see. Okay, I got a few people. Okay.
Yeah.
I can stay. I can stay for a few minutes if anybody wants. If nobody wants, then it's my lunchtime, and I will thank you all for listening.
Yeah, as Coleman said, if you could please provide your session feedback. Certainly, the risk curve resonated a lot with myself, Coleman. There are always basics, as you've put it, that you've got to have right in the first place.
Yeah.
I think the struggle we have as auditors sometimes is the scale of the platform. There are so many different components and so many different moving parts. You'd like to focus on, something for a change, if I can, at the top of the curve every now and then. And I mentioned on our last session that we had an interesting audit where we had a couple of non-mainframe people, young people on the team, and we spent a couple of hours going through everything with them, and they gave us some great challenges and asked us, well, why are you not going to look at that? And we were telling them, well, it's at the top of the curve.
Okay.
It's something that we don't think is as big as a risk as some of the things at the bottom. And
somebody has to make the call, for sure.
They do, yeah. And we decided in the end we'd add that on. We'd look at that as well as all the basics, and we actually found a significant control gap in that little bit. So,
okay. And yeah. for me, it's always a work in progress, and I keep coming back. People, we do. I'm working full on now with validated boot, and it's great. It's wow. It's wow. But it's very much at the top of the curve. And I don't know. It'll probably be obligatory in FEPS in America, but I don't know what Europe's going to do with that. It's always good to have, for sure. And depending. And the point that a lot of people can do this themselves before they buy a product or before they get outside help. And there's no point in getting outside help that will tell you that the basic rules are out. We had that a
Yeah.
couple of years here in France. A couple of years ago here in France, the auditor, they paid for an auditor to come in, and the audit findings was hundreds of pages long. I won't say who or why or how, but it's one of those things. And it wasn't a bank; it was an insurance. So it's again, the banks are much better at the moment, and insurance is just really starting it. I don't know how it is in the UK on that one.
I work for a bank, and we always get asked questions if there is any kind of hiccup, shall we say, on the
Right.
services that we provide. It hits the news and it goes into social media, goes into overdrive, and the first
Of
questions
course.
we start getting asked are, why did we not pick this up, or why did we not look at these things?
Right.
So we're always keen to, as you say, it is a moving target, and all you can do is just try and improve time on time.
Yeah.
But I
It's
think the key thing, as you say, is getting the basics right.
and then you're good. Absolutely. Cool. Anything else
Okay,
for the moment? No, we're good.
I think we're good.
Okay.
Again, just to remind everybody, if you could fill in the feedback form, and thank you very much, Coleman.
All right, guys. I'll see you next time. When is the next one? November, right? We're doing it
In the in-person event, I
in
think
person.
is either back end of October or early November. I'm not quite
Yeah,
sure of
because
the dates.
I don't really get a kick out of this because I don't see anybody. I can't look anybody in the eye. I can't look at it. Did you get that? Did you get that? And
Yeah.
normally I do a show, but there we go. All right, David. Thank you very much, and
Okay.
have a good afternoon. And I'll see you next time.
Yep. Thanks, Coleman, and
Take
thanks everybody.
take it easy.